Redstone 70, line difference and distance progression. IED and application configurations are found. IED configuration is the relay stinger. These configurations are specific to the relay. Binary input, output, transfer modules of CT and VT, and line data communication module for fiber connecting local and remote ends. Which setting group is active? Wokumam. There are 6 setting groups in the relay. This communication module is specific to the fiber that connects between the local end and the remote end for the data. I find settings specific to the setting group. Which one of them is active? You have 6 setting groups in the relay. In this station, you will find the frequency in ABC sequence, the station name, the relay name, the station number, and the relay number. You will also find a station specific to the disturbance recorder. We will see all of this in detail. As for the application and configuration, like leaving a company, and the application itself, it is exactly about introducing yourself to the company. It is the means of communication between you and the company you are applying to. The exact same idea applies here. The relay is currently present and you have the protected object, which is the underground feeder or overhead line. I want to know what the communication between them is. It is your protection functions. So the application configuration contains all the protection functions based on which the relay will recognize if there is a problem with the overhead line. Based on this, it will start performing its role in protecting the overhead transmission line, underground feeder, or whatever type of relay, whether it is protecting a transformer or a bus bar. If you open the hardware configuration, I will click on it first. This hardware configuration will show me the relay's appearance from the front and the back. Here, I will click on the power subline module. Here, I will find a set of cards, and here I will find the line data communication module and the transformer module. Here, I have the line data communication module and the transformer module. First of all, these LEDs are fixed. You cannot place them elsewhere. Therefore, when you go down, you will find that the color of the LEDs takes on a color like this milk, and it is fixed, meaning you cannot change this card. As for the second set of cards, you will find that each card is designed for you. Or they have chosen for you a type, for example CO or the card B3, you will find they have chosen a binary input module. This card can be replaced with any of these cards without any problem, but you have to think when you come to change here and say binary output module that the relay is already a binary output. You must actually install a binary output module. The idea is that all these cards can only accept these types. But you cannot come to me with a transformer module and say, it takes the card between the module symbols. This card cannot accept anything other than the module types that are all transformer modules, whether it is 12 current, 6 current, just 7 current and 5 volt, 9 current and 3 volt, or 6 current and 6 volt as we use. And this card, which has a fiber communication card, you will also find it only accepts certain types. In it, the fiber card, the card will also not accept anything other than certain types, right? Cards related to communication cannot be placed in a transceiver module or given an input or output module position. Alright, if you change the card, there's no problem. You can choose the type of card and give it a name that will appear here, like we might name it PEM_3, and it will appear here. You can give it a name and perform a reset, or perform a reset to be able to perform a reset to be able to perform a reset. So you can identify this card on the system that it belongs to. There is no change. The first thing is to open the banner input module. If you open the banner input module, you will find it consists of 16 banner inputs, and here there are labels. You cannot name them from here. You cannot name them by double-clicking or right-clicking. It tells you that you can name them in any way. The naming is done in the design of the template. We right-click here and open the template design. Here, we open. In the application, you can change the designations of the banner input, and based on that, if you follow the relief, the designations will be downloaded in this place. This will make it easier for you to enter the city banner input and look at the banner input you want programmed with something like, for example, if you want the banner input CB Robin or 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 CB Robin. They are merely names that make it easier for you to read the names of the banner inputs or understand their meaning. Even in the application itself, you can know the banner input that you want. If you recognize the banner input and then it is written next to it, circuit breaker Opal, then you have identified it. In the end, it tells you whether this disaster is working or not, and then there is something called debouncing binary input, meaning if the binary input 125 comes but is intermittent, it has a certain limit. The topic of OR means that if I get 125 but it's intermittent, like it comes and goes, and that means it has a certain limit. If it is less than 30 Hertz, then this binary input is considered okay. So it tells you that oscillation release will allow the binary input to release and become active. But if it is above 40 Hertz, what does that mean? It means it won't work for me. It means this binary input is cutting off a lot, and therefore I won't consider this binary input block even if it was actually coming. But the problem is in chattering or debouncing, I won't consider it valid. The binary output module consists of 24 binary outputs. The naming is done in the application configuration, and it performs the function of on and off, or the card on and off. The transformer module includes the CT and VT. So as you can see, 6I, 6U, 6 current, and 6 voltage. 6U, the third olive color, you find it good. Here you will find some names, and these are named as per the application configuration and the setting from the CT. The CT polarity is towards the object, or from the object. Of course, we know this story. If the CT is from its star point towards the protected object, which is the underground feeder or overhead line, it is set towards the object. If it is reversed in the opposite direction, you might say it is from the object, so it sets 180 on 180, making the black 0 again. And you place the strategy in all of them, then you set the filtration to 132 over 115. What matters to me in all of this is the transformer part. Sometimes the relay comes with its card, and the transformer's medium has its nominal current at 5 amperes. Therefore, the following happens. When you bring me a CT with a ratio of 2001 and you connect it to the input, which is 5 amperes, how will it read the 1? It will read as 0.2. Therefore, you must certainly consider that if you take a transformer with 5 amperes, its analog is 5 amperes, you will find that 1 ampere is approximately 0.2, which is wrong if you take a transformer with a ratio of 1 to 5, it is 0.2. It's all wrong, all right? Which means approximately 1 over 5 in it. And at the same time, if your CT is 2000 over 5, it will be wrong, because that means there is a large current flowing continuously in the CT, which is rated for or can handle up to 1 ampere. Maybe it can handle 3 amperes continuously, but not 5 amperes continuously. Excellent. Next, we come to the line data communication module. The line data communication module includes the settings for the fiber optic, which connects between the local end and the remote end. The first thing it tells you is the channel mode. Do you want it off, on, or out of service? Well, if you are going to connect end to end, then the station will be operational. So you obviously set it to on and assign an address, as we will see shortly. Right. That's good. If you want the fiber to be completely out of service and not use it, what will you do? Set it to out of service. Why completely out of service? Because if you operate it while there's an issue, it will create a differential block, as I mentioned earlier. Don't come and tell me that we must wait for the fiber or not. This is in the case of satisfaction, but don't rush the channel. Let's find a solution. So, you will set it to out of service, meaning it's completely out of service and the fiber is not present. Good, yes, stop. So, what's the purpose of this stop? The purpose of this stop is if I want to test a relay. Just one, meaning I have a relay here at the station and it's not yet connected to any other relays. How will I test this relay? As you know, in any relay, like for example, you might have a test loop back in the cell that you enter into test mode. You live in test mode supervision. You enter a person and test it. And for example, in Siemens, you perform test mode. Here, it's the same thing. Here, I don't do test mode. I make the communication off for me. What does this do? It considers the timer healthy. And as long as the fiber is considered healthy, for you, the differential is not loaded, and thus you can test the differential, or you have other capabilities. You can perform an external loopback on the relay, meaning you place send with receive and receive with whom, with the send, and between you, send 1 and 2. Is that clear? Yes, it's clear. I will leave it off because I will test the differential in a little while. After that, we press on the address mentioned in the description to 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 the description. And on the other side, 22 was 12. Next, we come to something called the differential sync. I have two here, a modem and GPS. Let's quickly talk about what's here. The study says in resistance protection, resistance should be the current benchmark of resistance. Resistance. Now, you have the brush investigation between two sides. Each side of the sleep works on achieving the brushing between the two sides, each side of the sleep. Send a sample to the current every 3 milliseconds or 4 milliseconds. Excellent. Here it says that the data sent between the two sides must be time components to avoid errors. Well, what is this? There must be a design and time between the two. But I need to know what the impact is between me and the others, meaning that there is a specific sample. I will input it into the differential processor, okay? Well, this sample originally has a sample in the others, but there is an impact because this sample followed me. Right. Or am I wrong? This means what I will see now. There is a sample of reports of the sample that was operating at 4 milliseconds. If I repeat it with the sample I currently have, I will have a problem because I have a sample with a value, but the sample I have was equivalent to a value of 4 milliseconds. If I repeat it with the current value, I will have a comparison. So it tells you if you have examples in the examples. Just 0.1 milliseconds will cause a 3% error in the examples. So imagine if you have a 1 millisecond error, it will cause an error in the examples. 30% corresponds exactly to 4% at 60 Hertz and 38% error, and consequently it told you. In line differential protection, the time coordination is made with the so-called echo method. The first method, which is the echo, and this echo itself can be complemented with GPS synchronization as an option. But basically I have echo and I have GPS. Okay, let me tell you, each relay has a local clock. And this local clock is accurate. That's good. This clock makes time tagging of telegrams. So now I want to make a method that I just really would simply want to know. To read the sentence to execute it later, she said that the IED has an accurate local clock with a very small time drift. This clock makes time tagging of telegrams, and the echo method is then used to find out the time difference between the clocks into two ends of power line. From this sentence, we understand that we have two things. The local clock of the relay, which we said is supposed to be accurate. It performs a task called time tagging of telegram. Now it tells you the transmission time to send a message from P to A, meaning here the relay at your P sent a message from P to A. You had T1 arriving here at time T2. It sent it to you at time T3 and returned to you at time T4. The part where you send a signal from here to here, it sends the local clip to you and performs time tagging of telegrams. Was this good? Good. The echo now looks at the time difference between the clips at the two ends of the power line. So it told you, I will now get the delay time one way, and the difference time, meaning it sees the delay time one way, meaning it should move or return and see the delta t, which is the time difference delta t between the clocks in A and B, between A and between the two sides. Is that clear? Good. It told you the delta is done every time a telegram is received. Meaning every time you send it a signal, this signal is just something for the internet to see in it. The differences in the delay time between the two sides and the time difference between the two sides. So now every telegram you send, it calculates the details for us, and then the details of the details are used for the procedure, and you enter the second path. And since the scattered attempt ends here, the function comes, and then I see that I have sent the telegram and it returned to me. And I saw the send time and the receive time. And it calculated the delete time and the time difference between the environments that perform the echo method. And this echo method that performs this action will calculate the time difference and the delete time. And after that, this device or system is designed to specifically and accurately tell you that it is used to provide the current measurement in a consistent and reliable manner before applying the moving equation. The children did not start before the internet improvement begins. From the comprehensive internet, before B. The comprehensive internet can be used from the comprehensive internet. Transmission network with varying signal propagation delay as long as there is a delay symmetry between send and receive, meaning the same send and receive. The send and receive delays are the delay variation can depend on the signal. Going different routes in the network from time to time. This means there can be a delay variation, or this delay variation depends on where the signal is weak. If you have two relays but don't know what to call from one relay to the other. But I told you already, when delay symmetry occurs between the two sides, meaning send and receive, here delta t that you were calculating, which is the average you were getting above, you were adding t1 plus t2 and t here. Here it is. You add t1 plus t4 and t2 plus t3. And you subtract this noise to get the part in the middle here and here, and divide them by 2, so you can see what you have here. This is the send time, and this is the receive time. You added t1, yes, from t1 plus t4, and t2 plus t3, and you subtracted the two from each other and divided them by 2. So if you have in the part of send and receive, then all you have is this delta, which is no longer working correctly. And now it must be used. So at that time, what is supposed to happen? It should work. Okay? So of course, that's why you need to have what? With. Okay? So it's here. And it tells you that you are relying on the echo without GPS in the case where you have send and receive time are equal. This part is up to here. As long as there is a delay symmetry, that is, send and receive delay times are equal. Okay, but if you have delay symmetry is lost, this delta is not fragmented well. Okay, so including the GPS option means that there will be, in every IED engine, the location of the IED engine is recorded appropriately. In the passage of 1 microsecond, you can determine the limits of 1, which are the same details that contain a microsecond, and therefore it unifies the time here and the time here today at the same starting point. And thus, what can it do? It can now detect asymmetric transition, time guide, which is the asymmetry in the time guide, and compensate for it. All right, I don't want more than that from the echo and GPS concept. So it was said that differential sync can be done through echo and can be done through the G. Yes? These are usually what is used in the stations. Echo was initially using GPS, and sometimes issues would occur due to, for example, weather conditions or something like that, causing problems with the GPS. and sometimes its signal would still be weak. So it is no longer relied upon. Instead, they rely on the echo method. Then it tells you if you were choosing GPS. Here, if a GPS error occurs, what is supposed to happen? So it is written here in the manual, telling you if you were using GPS and there is a GPS signal loss. The synchronization of the line. The differential function will continue for 16 seconds based on the stability in the local IED clock. Meaning, if the GPS fails, it tells you that it relies on the stability of whose clock? Your IED clock. Meaning that it's over. I mean, you were just a moment ago. As soon as it leaves you, it's over. Things will happen automatically in the official box, and so on. It tells you that it will cause the line differential function to continue. 16 seconds relying on the stability of the IED clock. And then if you choose the option called block, it will block the line differential function. And if you choose the setting called echo, you have two settings there, either echo or block. If you choose echo, it said, we'll make it continue by using the echo synchronization method. The echo will start again to calculate what's in it. The telegram is sent, calculates the essence of send and receive, and gets delta t. It determines how much the type error is and starts inputting it to the differential before it does anything before the differential algorithm starts, and so on. It tells you. You should see that using echo in this particular scenario is primarily due to the fact that there is no error in changing the phase. We wait for echo to go to the communication area without any issues. It tells you that the master or slave performs a test of the master or slave in the communication area, and we will not be risking the synchronization of moving internet for moving vehicles. Shall not be mistaken for synchronization of line differential current samples. Now I want to know which one of them is my master, which one of them is the slave? Because what does it do in your mind? It tells you. Where is the master and slave in the communication system between the two? And its usage to do what? Synchronization of line differential current samples. Okay, so it tells you if you are using direct fiber, you put one master, and the other is the slave. So one of them is the one doing the synchronizing in the line differential current sample and mastering the other. This means one is the source and the other is the slave. So the source is the one that adjusts and knows in the guide how much and knows everything. And it does the synchronizing in the communication and sends to the other, telling it you will do this and I will do that. So one is the source and the other is the slave if you choose. So one side and the other side. What if you are using? As a manager, you oversee operations in various cities, each with unique challenges. You also manage a multiplexer, a device that combines signals for efficient communication. Both cities and the multiplexer are considered intelligent electronic devices, IEDs, crucial for modern infrastructure. Between the two sides, who is it? It is the model itself. You close the tools and reach to. When you take a picture, well, no, the computer processes the image in a way that is both efficient and effective. This ensures that the final result is clear and precise, capturing every detail with accuracy and maintaining the integrity of the original scene. Starts to synchronize between the two sides as a communication sync through the modem and the multiplexer continuously. And this tells you that if the fiber is from 0 to 1 kilomet, then this is used for the modes. And you use it for the modes greater than 1 kiloohm. And the transmit current has become very important. And before I talk about it, we have the transition to assist in the transition. And when the transition occurs, we have the transition to assist. In the transition, the bank is unlocked. After the transition time, or the pen sharpness is unlocked after its time tick.